EE World, I'm Martin Rowe. At the 2022 International Microwave Symposium in Denver, Colorado, Keysight Technologies showed a test bed that's being used for 6G research. Now, as the rest of the world tries to figure out how to make money from 5G, engineers have moved on to developing 5G advanced and doing some initial research for 6G. Part of that research has to do with using frequencies, the so-called sub-terahertz, but really it's anything above 100 gigahertz. 140 or so gigahertz seems to be popular right now. Keysight's testbed transmits using a Nokia radio on glass. This is something that Nokia Bell Labs has demonstrated and has been spoken about at various other conferences. The 6G radio on glass then transmits at 141 gigahertz to the Keysight test equipment, where they're using a signal analyzer and a waveform generator to generate the signals. Applications engineer Randy Becker will explain to us how the test system currently works. So here we have some equipment that's going to show some of what's going on in the research for 6G. And Randy Becker is going to tell us what they've got here, other than the fact that it's keeping me very warm.
Well, if you're going to have a lot of power, you get some warmth with that sometimes. But what we're showing here is Keysight 6G sub-terahertz testbed. And really, people want the flexibility to generate really wide bandwidth signals and analyze these really wide bandwidth signals at even higher frequencies than we're using for 5G. In this quick demo, what we're doing is generating a fairly modest bandwidth signal, but we could do signals up to 20 gigahertz wide. We're running the baseband IQ out of the arbitrary waveform generator into a Nokia radio, their radio on glass technology, where we're generating this signal at 141 gigahertz. That is then feeding this phased array antenna on the end, where we're dynamically controlling that beam. You'll see the positioner move periodically. When it moves off axis, we electrically steer the beam back to the probe antenna over here.
Okay, there's the antenna. Yep.
Here's the antenna. And behind that we have a VDI down converter where we take it back down to an IF. We feed it back into this chassis where we have the digitizer. We capture those signals and then we send it to the VSA software for analysis, which you can see on the middle screen here. So here you see a bunch of the usual metrics like the constellation. You can see the spectrum. The span here is just under 2 gigahertz. And I'll even put my hand in front of this. Normally I wouldn't do that, but for you, I'll do it. Right? You can only do that so many times before something bad's going to happen, but
burned your hand yet.
Not yet. But you see that it did go away. So in fact, we are transmitting at 141 gigahertz over the entire span of our demo here. So this just shows some of the things that people are doing in 6G and some of the flexibility that we have to offer to help them get their job done.